Good morning. You've got a packed catch-up today, 17 videos from the last 25 hours, covering everything from AI strategy and agent tooling to Apple leaks, Mercedes labor disputes, and a PlayStation consumer rights controversy. Grab your coffee, this one's thorough. Let's start with what might be the most strategically useful thing in today's lineup. Nate Jones from AI News and Strategy Daily put out a really sharp, measured argument about why cheap AI models are table stakes, not a strategy. His core thesis: when execution gets cheap and universal, the competitive advantage shifts entirely to imagination, knowing what to ask for in the first place. He builds the whole argument around a fascinating two-part experiment by Mitchell Hashimoto, the co-founder of HashiCorp and creator of the Ghosty Terminal, one of the most respected working engineers alive. Hashimoto tested 3 models on the same routine task: implement this feature, build this thing. A budget model came in under $1 and finished in minutes. GPT-5.5 cost about $1.50. A frontier model called Fable 5 took 40 minutes and cost $9. The output quality? Indistinguishable across all 3. Nate says that result triggered a wave of hot takes telling everyone to route everything to cheap models, and he agrees with that advice, as far as it goes. But then Hashimoto ran a second test, and this is where Nate says the real lesson is hiding. He handed Fable 5 a gnarly piece of systems code he'd written himself and asked it to optimize it. 2 hours, $40. The result was a level of performance Hashimoto said he could not have achieved on his own, and this is someone who is, by any measure, one of the best engineers in the world at exactly that kind of work. Nate's central question is devastating in its simplicity. Who assigned that task? It wasn't on a backlog. No PM prioritized it. It didn't exist as a task until Hashimoto, an expert with deep model experience, suspected something new had become possible and spent money testing that suspicion. The ceiling on what AI is worth to you is not the model price or the prompt pack. It's the size of your list of things you know how to ask for. That's what Nate means by imagination. He's careful to say this isn't anti-execution. Execution matters enormously. It's what gets multiplied by imagination. The point is about what sets the multiplier. And right now, because a million people are running the same known tasks through the same shared prompts and public playbooks, results are converging. AI didn't make outputs generic. It revealed that differentiation is hard and is fundamentally a human responsibility. He uses BlackBerry versus Apple to anchor this historically. BlackBerry had the best keyboard, best email, best security, and market leadership. It didn't fail at execution. It executed superbly inside a category everyone had already imagined. Apple imagined a different answer to what a phone even was. Same industry, comparable execution muscle, imagination set the multiplier. The concrete frontier model example he really lights up about is a workflow someone built using Fable 5. It uses Google Maps to identify porches in a geographic area that are unshaded and receive full-day sun in regions where summer temperatures cross a certain threshold, then retrieves a 3D model of each property, generates a custom mailer with specific data about that homeowner's porch and a visual rendering of what a covered porch would look like on their specific home, and mails it. Cheaper models can execute portions of that pipeline once it's prototyped, but getting the spatial and logical reasoning working together, managing the tool integrations including Blender, and translating it into a business flow required the frontier model. And critically, the hard part wasn't writing the prompt. It was having the imagination to realize that a new kind of hyper-targeted, hyper-specific, hyper-relevant marketing had become possible at all. He's got a great analogy about factory electrification. When factories switched from steam to electric power, productivity gains were minimal at first because they kept the steam-era layout. All machines still clustered around one central drive shaft, just with an electric motor bolted on. The payoff came when a new generation of managers redesigned factory floors around what cheap distributed motors made possible. The unit of change wasn't the motor, it was the building. Companies today are making the same mistake with AI, bolting it onto existing task lists and reporting on savings. The Stripe example illustrates redesigning the building. They migrated 50 million lines of code in one day versus an estimated 2+ months for a team. But the impressive figure isn't the one day. It's the years Stripe spent building test coverage, review systems, and internal expertise capable of verifying that volume of changes. You could point the same model at a company that hadn't done that prep work, and you would not get a one-day migration. His leadership warning is pointed. You cannot solve this by hiring one imaginative person. That $40 Hashimoto job required imagination, deep context, and permission to ask, all in one head. A hired AI visionary brings imagination, but none of your company's context. His practical test. How many people on your team are allowed to pose a $40 or $400 question to a model today without asking anyone? If the answer is nobody or very few, you have an imagination constraint. Worth a read on his Substack too. He has the full written version with the Stripe breakdown and counterarguments. Staying in the AI agent space, let's talk about a talk from the AI Engineer Conference by Raphael Kalandadze, who runs a 3-person company called Wandero AI that builds travel itinerary agents. His talk was about what he calls the missing layer after launch, the post-launch feedback loop that almost nobody builds. He opened with a series of pointed questions. How do you know if your agent is actually working in production? How do you watch hundreds or thousands of real conversations every day? How do you detect problems you don't yet know exist? Most agent-focused talks end at the moment of shipping. Raphael's entire talk is about what happens after. His core observation is that monitoring is harder for agentic systems than for classical software. Normal software has predefined flows and a fixed feature set you can test. Agents have what he calls endless coverage. They handle whatever the user throws at them, and you cannot enumerate all possible conversations in advance. And the deepest part of the problem, you lose the feel for your own system. You can't tell whether it's getting better or worse. He identified 3 specific reasons this is a genuinely novel problem. First, LLMs are non-deterministic. The same input can produce different paths, and even a slight modification can cause a completely different trajectory. Second, and most critically, failure hides itself. An agent can struggle mid-task, stumble around, recover via luck, find workarounds through different tool calls, and still produce no red alerts. He referenced an Anthropic blog post noting that agents sometimes mark tasks as complete without checking whether they actually worked. Third, the tool surface is enormous. Long-running tasks may involve hundreds or thousands of tool calls, subagents, code execution, terminal use, third-party APIs. You often don't even know what you're looking for. He also flags a 4th issue. Finished doesn't mean helpful. His specific example from Wandero, a user asks to build a trip itinerary, the agent runs the flow, finishes successfully, but used a wrong service and made pricing calculation errors. Technically a success, practically a failure. His solution architecture has 3 flows. Flow 1 is the log monitoring agent, runs every hour or every 15 minutes on a rolling window of logs, checks whether users got stuck, and either files a PR or sends a Slack alert. PRs include a written description of the problem, metadata, mermaid diagrams, and HTML artifacts for a quick visual glance. But here's the clever part. There's a separate review agent that checks the PR from a fresh perspective with no prior context about the problem. It actively tries to criticize the PR, scores it, and either requests changes, closes it, or passes it to a human. He says the PR and review agents together send 10 times more PRs per day than his 3-person team does. A PR can be ready about 30 minutes after a problem is detected. Flow 2 is the session analyzer, designed for higher-level understanding of system health. It scores every conversation, runs many subagents, consumes more tokens, but connects patterns across hundreds of conversations and provides an overall health assessment. He demoed a dashboard showing total sessions, cost, average score, success rate, trends, and AI-generated insights where the agent connects dots across conversations to identify recurring patterns. He runs this weekly or twice a week. Flow 3 is computer use agents for UI-level simulation. Logs can't surface problems that only appear in the browser. His team built a computer use agent that opens the browser, logs in, simulates a customer session, and inspects what the interface looks like. They initially used Codex but found it slow, so they built a specialized skill that knows their website's DOM structure, which is much faster. His closing line was sharp. The moat is not the model alone. You need to build the system around the model that watches itself, understands itself, and improves itself. Shipping is easy today. Closing the loop is the hard and differentiating work. Also from AI engineer, Soheil Feizi, Associate Professor of Computer Science at University of Maryland and founder of RELAI, gave a more academic but really rigorous talk on what he's calling verifiable continual learning, or VCL. Think of it as the formal framework underneath the kind of system Raphael was describing. Feizi's framing is simple. Humans learn from experience, interact, get feedback, improve. The goal for AI agents is the same loop, but making it real and rigorous requires solving two hard challenges. First, he established that agent improvement isn't just about model weights. There are three distinct layers where learning can happen. The model layer, where you change the actual weights. The harness layer, which is the context engineering scaffold, prompts, skills, tools, code, workflow logic. And the memory layer, both in session and persistent, where facts and distilled skills can be written and retrieved. This layered framing matters because the right fix for a failure might live in any of those three places, and reflexively reaching for fine-tuning is often the most expensive and least appropriate choice. Challenge 1 is getting feedback. In development, you have benchmarks and explicit evaluators, relatively easy. In production, you have logs. A session log might show a dissatisfied user but provides no explicit grade. You can use automatic LLM-based analysis of logs, which is scalable but potentially shallow, or you can have human experts review a small number of logs for high-signal, high-quality feedback. But here's Feizi's critical point. Log plus feedback is still not enough. It's not testable. What you really need is a replayable learning environment, a simulation you can rerun with defined grading. That means inferring a distribution from the one observed instance, deciding whether to use real or mocked tools, synthesizing realistic user personas, and defining evaluators. Once you have that, you can run different agent candidates against the environment, measure performance, and verify fixes. Challenge 2 is acting on that feedback. He walked through the existing approaches at each layer. Model layer approaches like SFT, DPO, GRPO, and LoRa are expensive and require benchmarks and explicit evaluators. They cannot be applied directly to raw logs. Harness layer approaches like feeding logs to a coding agent to modify prompts work without a benchmark, but are, in his words, vibe-based. You can't verify the fix even for the observed sample. Memory layer approaches like writing facts via Letta or Mem0 are cheap and fast, but changes are unverified with no way to confirm the written fact, resolves the issue, or doesn't cause regressions elsewhere. Verifiable continual learning is his proposed solution. The definition: improve an agent from its own experience where every fix is proven to help and proven to break nothing that already worked. 3 steps: make the failure a replayable, gradable task, measure the delta before and after the update, run a regression test to confirm prior tests still pass. His 4 principles: replayability, turn a one-off failure into a rerunnable test. Holisticness, one failure may have multiple causes across multiple layers, and the fix must be rooted to the correct layer with the smallest durable change. Lifelongness, a new fix must not break past successes, and regression avoidance should be built into the optimization objective itself, not treated as a post-hoc check. Efficiency, the loop must run frequently, so the cost structure at each layer matters enormously. The demo was convincing. He built a benchmark around a fictional support agent with deliberate regression traps, so that overfitting on the latest fix will break previously passing cases. He gave the system a simple instruction: handle rude and adversarial callers. From that instruction alone, RELAI generated a learning environment with personas, intents, mock tools, and success metric evaluators. The agent scored 78% on a subset evaluation, 87% average overall. 1. RELAI optimize call later, 97%. 10 percentage points up in a single loop. His emphasis: the loop is lifelong, improvements compound, and previously working behavior stays intact. Rounding out the AI engineer talks, Pietro Zullo from Manufact gave an evangelistic but practically grounded talk on MCP apps, which are MCP servers that return interactive UI widgets alongside tool calls. If you haven't been tracking this, It's moving fast, and Pietro made a compelling case that right now is the moment to publish. He set the timeline first. MCP launched in 2024. In late May 2025, a proposal called MCP UI emerged for MCP servers to return UI components, which generated serious community excitement. ChatGPT released an app SDK. Both ChatGPT and Claude quietly opened MCP stores late in 2025, though initially restricted to design partners. In January 2026, MCP UI formally became MCP Apps, the official extension of the Model Context Protocol for returning UI elements. The stores are now open. Mechanically, the difference from standard MCP is simple but significant. Instead of returning a JSON string, a tool returns a widget rendered in a sandboxed iframe, displayed inline beneath the streaming model response. And it's bidirectional. The iframe can send messages back to the host application. Pietro walked through the specific primitives. Send follow-up message lets a button in the UI widget inject a message directly into the chat. He used a shoe product example where clicking Learn More on a product card sends a follow-up query to the model. Claude displays it in the chat input first and lets the user choose to send it, while ChatGPT just fires it immediately and starts streaming. The streaming token updates pattern is one Pietro called genuinely exciting. As the model streams tokens into tool arguments, the UI updates incrementally in real time. He demoed this with an Excalidraw MCP server where Claude reads instructions, then streams mermaid syntax tokens into a canvas that updates live as they arrive. He also showed a Remotion MCP app rendering a React-based video inside a widget as tokens stream in. He called it some of the coolest DMOS he'd seen. Two other primitives worth flagging: the privacy-preserving output split, which lets a tool return two distinct outputs simultaneously. One for the UI widget showing sensitive personal data, and one for the model that just says, the user is seeing their private information in the widget above. This makes MCP viable in privacy-sensitive domains where you don't want raw personal data going to the LLM provider. And request display mode, which lets the widget request different display contexts. Inline, full screen, useful for video editing interfaces, or picture-in-picture. Client support is solid. Claude, ChatGPT, Codex, Cursor in both agent and side chat modes, VS Code. His practical advice for developers: detect client support at connection time and conditionally return UI elements, with model-readable fallback output for clients that don't support MCP apps. Manufact's own stack. Their open-source MCP use SDK has over 8 million downloads and 10,000 GitHub stars. Their inspector tool lets you test MCP servers locally. Their cloud platform handles deployment, evals, testing, team sharing, and publishing checks before store submission. His closing pitch: stop looking at dashboards in separate tabs, ship an MCP app so users see it directly in Claude or ChatGPT. Shifting gears slightly, still AI, but the product and communication side. Veronica Hylak, founder of Hey AI, gave a punchy and practical talk about why technically impressive AI products are failing in the market. Her thesis: it's not the engineering. It's that founders cannot explain what they built. She opened with a satirical pitch dialogue. She played both the founder and the confused buyer, where the founder keeps trying synonyms. Agentic AI orchestration platform, agents talking to agents, autonomous intelligence for your workflows. The buyer never gets it. The joke landed because everyone in the room has lived it. She then introduced her three-part framework. Part 1 is the wound. The wound is the customer's single biggest pain point. The moment they want to throw their laptop out the window, her rule is absolute: do not start with what you built. The first words should place the listener inside the customer's everyday experience, not your product description. She cited a real negative example: a Series B startup that opened with, "We built an agentic orchestration SecOps platform for enterprises." Her critique: nobody feels anything. Then she rewrites it: security teams are exhausted managing dozens of disconnected tools. Alerts live in one system, tickets in another, vulnerabilities in another. And the real investigation is buried in Slack threads and random screenshots. We fix that by putting it all into one place. The listener now feels the overwhelm. The format: identify the wound, say, "We fix that," then explain how. 20 seconds. Part 2 is making the product click. Her test: can a 17-year-old understand what you do? If not, you'll lose the room. Her technique is to tie the product to a viral story or widely understood cultural moment. She used the McDonald's AI drive-through disaster, those videos that went everywhere showing the AI putting bacon on ice cream. If your product is in agent monitoring, don't say, "We're an agent observability platform." Say, "If McDonald's had used us, that drive-through never would have made it to TikTok." We catch when AI agents go off script and give teams a chance to correct them before it becomes a PR nightmare. She praised Devin, the AI software engineer, and we're a smoke alarm for AI behavior as examples of instantly clear framing. Her caveat: these aren't precise technical definitions and don't need to be. They're front doors into the rest of the conversation. The technical version comes later, after the story has created buy-in. Part 3 is showing the transformation. Many founders describe the product but never show what actually changes for the customer. "We improve code quality with AI" is empty. The listener can't visualize what their life looks like after buying. She calls for an explicit before and after. Before, your support team spent 30 minutes digging through docs and tickets. With us, they ask one question and get the answer in 10 seconds, with sources attached. The old world and the new world are both visible. Her closing argument: 15 years ago, great products could let the market find them. That's no longer true. The products with the clearest stories are the ones that get funded, bought, and talked about. Great tech that nobody understands dies quietly. On a more hands-on AI note, Matt Maher ran a genuinely interesting bake-off between GPT-5.5 via Codex and Claude Opus 4.8 via Claude Code, building a radial Mac launcher app in native Swift. But the real story wasn't which model won. It was that goal mode beat standard agent mode in almost every meaningful dimension. Maher ran 4 simultaneous builds: Claude Code straight, Claude Code in goal mode, Codex straight, and Codex in goal mode. All kicked off at the same time, all with the same spec. Before comparing results, he walked through how he designed the visual spec, which turned out to be its own interesting process. He started with Claude design, asked for 6 radial ring launcher variations, found them too mechanical. He pivoted to ChatGPT's image model for broader ideation, more creatively free, he said, and got something graphically more interesting. 1 ring of icons, a center button for switching modes, a second ring for mode labels. He took a screenshot of the bottom variant he liked, dropped it back into Claude design with a more focused prompt, iterated on animations, icon transitions, navigation, and refined it over several passes. The resulting design zip plus an exported prompt formed the spec package for all 4 builds. He also mentioned Open Design, an open-source Claude design alternative for people without an Anthropic subscription. Here's how the builds came out. Claude Code straight took 36 minutes. The concept was present, arrow keys navigated, an actions menu appeared, but the settings panel was broken. Maher called it janky. Codex straight finished in about 28 to 30 minutes. It actually worked. Launcher appeared near the mouse cursor, rings were navigable, settings panel appeared with distinct work and web modes. He called it a good starting point, though it missed things like the animated outer ring. Codex goal finished in about 25 minutes, actually faster than the Codex straight build, and the visual quality was noticeably better. The circling animation was correct, the launcher tracked the cursor across monitors, ring layout was tighter, Google actually loaded when selected in web mode. And here's the number that surprised Maher. Goal mode used fewer tokens than the straight Codex build. He explicitly said he did not expect that. Claude Code Goal took 48 minutes, the longest build, but it was also the best result overall by a meaningful margin. It was the only build that provided clear instructions on how to run the app after completing. Icons animated in with a disclosure effect. Colors from the design spec carried through consistently into the settings panel. The settings panel was polished, with color customization options. Maher noted one issue: a classic CSS snapback when rotation loops from 360 to 0 degrees, and the outer ring animation was absent. But overall, he said it felt like it represented the app from the design spec in a real way. His verdict: Claude wins essentially hands down. The token and cost finding is what made him genuinely excited. Claude straight used nominally 36 million tokens, but 35 million were cash reads, effective tokens roughly 1.17 million. Claude Goal used approximately 500,000 tokens, about half the effective cost of the straight build, while producing a far better result. Goal mode, he summarized, is for when requirements are intentionally open-ended. You tell the agent the goal, what it can measure, and the threshold for done. It loops, checking its own output against that bar until it decides it's met it. The agent figures out what else needs to be built rather than being constrained to a predetermined plan. Stepping back to the broader computing landscape, Christopher from Explaining Computers delivered his mid-2026 channel update, and it was substantive enough to stand on its own as industry analysis. 3 big topics: NVIDIA's RTX Spark, RAM prices, and the evolving Linux user base. On RTX Spark, Christopher was clearly excited but simultaneously worried about implications for hobbyists. He noted that just 8 days after he published a video predicting that CP, System in Package designs, would define the future of home computing, NVIDIA announced RTX Spark in partnership with MediaTek. The top-tier NX1 chip features a 20-core Grace ARM CPU, a Blackwell generation RTX GPU with 6,144 CUDA cores, and up to 128 GB of unified RAM. The entry-level N1 chip has a 10-core CPU, 2,024 CUDA cores, and up to 64 GB RAM. NVIDIA claims the NX1 can run powerful AI agents locally and play AAA games at 1440p at over 100 frames per second. Launch partners include ASUS, Dell, HP, Lenovo, Microsoft, and MSI, with 30 laptops and 10 mini PCs in the rollout. Christopher quoted Jensen Huang, "For 40 years you launched apps, click, type. With RTX Spark and Microsoft Windows you ask, and the PC does the work." He then identified 2 implications he considers at least as significant as the AI angle. First, RTX Spark uses ARM cores, not x86. This will massively accelerate Windows on ARM. The mainstream market will soon present 5 distinct platform choices: Intel x86 Windows, AMD x86 Windows, NVIDIA ARM Windows, Qualcomm ARM Windows, and ARM Max. Second, integrating CPU, GPU, and RAM into a single package accelerates the trend towards sealed, non-upgradable devices. He acknowledged enthusiasts instinctively dislike this, but frames it as unsurprising given that the dominant home computing device is already the smartphone, which is entirely non-upgradable. He predicts retro computing will grow as a hobbyist frontier, and that for those wanting control over modern systems, the path forward will be using AI to mod applications rather than selecting and upgrading physical hardware. On RAM and storage prices, the situation remains bleak. Jensen Huang told Reuters in June that memory shortages will persist for several years. An AMD executive told TechRadar that RAM pricing won't normalize until 2028. 6 new manufacturing facilities are under construction by the 3 major RAM and flash storage makers, most focused on high-bandwidth memory for AI data centers, with most not reaching full production until 2027 or 2028. Christopher highlighted a Framework CEO blog post from April 2026 by Nirav Patel as required reading. Patel warned that there is a very real scenario in which personal computing as we know it is dead. His argument: memory, storage, silicon, and everything related to it is being consumed at unprecedented levels in a winner-takes-all race to an AI-first world in which access to compute is metered by the token. The cloud has greater economic output than the device in hand, so whenever supply is constrained, the cloud wins. Christopher said Patel is, sadly, almost certainly correct. On Linux, Christopher stepped back from distros and tech to address the shifting user base. He makes content for general, non-technical users and is increasingly getting pushback in comments from technical users who feel all Linux users should be able to configure the OS themselves. His analysis: not long ago, almost every Linux beginner was already technically skilled. Otherwise, they wouldn't have been experimenting with Linux. In recent years, many more non-technical general users have migrated, partly from Windows frustration, and they compare their experience directly to Windows. They expect drivers and basic functionality to work out of the box. The definition of beginner has changed, not the distro's self-description. He closed with an appeal for mutual respect and will continue making content for general users. A demographic note that genuinely surprised him. Over half his audience is now over 45, and the single largest age cohort is over 65, surpassing the 25 to 34 bracket. He believes older viewers are less likely to trust AI-generated answers and more likely to prefer watching a human explain something. Views are holding stable, while many tech YouTubers report falling views attributed to AI replacing YouTube searches. Now let's talk Apple, because this one is a lot. The folks at Max Tech put out a comprehensive leak roundup covering all 16 products expected across Apple's next 3 back-to-back events from September through November, drawing heavily on what they describe as an actual Tata data breach and Mark Gurman reports. The presenter was enthusiastic and fast-moving, clearly excited about the volume of confirmed information rather than just speculation. 3 events, 16 products, here's the rundown. September, the base iPad 12th generation should get an A19 chip, bumping RAM from 6 to 8 GB for better multitasking and full Apple Intelligence support. The iPhone 18 Pro and Pro Max get the most detail, and this is where the Tata leak comes in. Actual images and schematics were confirmed. The dynamic island is getting smaller, achieved by moving infrared sensors to the left side of the internals to shine from underneath the display. New confirmed colors are sky blue, a new silver gray, and cherry red, with color-matched back glass for a more seamless look. The A20 Pro chip uses 2nm technology with a new packaging approach that moves RAM off the top of the chip to the side with a metal enclosure for direct heat contact. A brand new vapor chamber cooler spans the entire internals, much larger than the 17 Pro Max, with improved contact to the chassis. The camera module is larger, confirmed by leaked documents as the Sony IMX905 sensor. Leaked code confirms the C2 modem is present, but US models will continue using Qualcomm's 5G modem because C2 doesn't yet support millimeter wave 5G. The front camera is confirmed at 24 megapixels. Pro prices are expected to rise by approximately $200. Also in September, the Apple TV 4K is expected to upgrade to an A17 Pro chip with 8 GB of RAM, enabling Apple Intelligence. The iPhone Ultra is the foldable dummy models showed a large crease-free display, with Apple reportedly solving the crease problem via a liquid metal hinge. It has the full A20 Pro chip, a battery up to 5,800 mAh, no Face ID, switching instead to side-mounted Touch ID. Expected price around $2,500. The HomePod Mini 2 gets the same design, possibly new colors, an S10 chip upgrade from S5, and a U2 ultra-wideband chip. The Apple Watch Ultra 4 sits under genuine uncertainty. One report says a major Apple Watch redesign with a new magnetic band connection is coming next year, implying no major Ultra 4 redesign this cycle. The presenter says it's genuinely unclear. Confirmed regardless, S12 chip, possibly the N1 wireless chip, satellite support, and a blood pressure feature. Apple Watch Series 12 is described plainly as a boring S12 chip swap. October brings the M5 Mac lineup. The Mac Studio with M5 Max and M5 Ultra is confirmed by Mark Gurman, with the M5 Ultra expected to be a massive performance leap especially for AI workloads. The MacBook, what the presenter calls the MacBook Ultra, the high-end MacBook Pro successor, gets M5 Pro and M5 Max chips with macOS Golden Gate, which has hints of touchscreen display support. Key design changes: tandem OLED display, dynamic island replacing the notch, thinner bezels, full chassis redesign for thinner and lighter build. The presenter says he will buy one on day one. The M5 Mac Mini and M5 iMac are both simple chip swaps. He recommends waiting for the M7 iMac, roughly a year to a year and a half away, for a more significant upgrade. November is the presenter's most personal section. The OLED iPad Mini 8 is his favorite iPad of all time, and he calls the upgrade insane. OLED display for dramatically better colors and contrast. A new chassis design reportedly removing traditional speaker grills in favor of vibration-based speakers for better waterproofing. The display may grow from 8.5 to 8.7 inches with thinner bezels. And the Tata leak confirms an A20 Pro chip with an actual image of the logic board. Expected price $599. He calls it an instant upgrade. The 14-inch MacBook Pro M6 is confirmed by Gurman. The M6 is the first 2nm Mac chip from TSMC. Notably, Gurman says the M6 series will only be the base M6, skipping Pro and Max in favor of jumping straight to M7 next year. Memory bandwidth increases from 153 to 200 gigabytes per second. GPU moves from 10 to 12 cores. No design changes. Expected $1,999. Rounding out November. The Apple Smart Home Hub, a long-delayed 7-inch iPad either wall-mounted or on a speaker base, with Face ID, FaceTime, Home OS, and app support, and the Apple Smart Doorbell, which pairs with the hub and features built-in Face ID authentication. AirPods Ultra and Apple's camera glasses are not expected until the end of next year. On the developer tools front, DIY Smart Code put out a sharp, skepticism-first look at Deno 2.9's new desktop feature, which lets you build desktop apps using the OS's built-in web view instead of bundling Chromium. The presenter was measured and deliberately anti-hype throughout, opening with the phrase, "before you believe a thumbnail," which made the genuine strengths land more credibly. The core problem with Electron that the video sets up: every Electron app ships an entire copy of Chromium, roughly 180 megabytes of browser, before a single line of application code runs. A typical Electron to-do list app comes in at 248 megabytes. Deno Desktop solution is to point a single command, Deno Desktop App TS, at a TypeScript file, and the result is a native desktop window that serves the UI through WebView 2 on Windows or WebKit on Mac and Linux, while the backend logic runs in Deno. Frontend and backend communicate through a direct binding in the same process, eliminating Electron's separate IPC channel. There's an escape hatch, a flag that bundles real Chromium if cross-platform rendering consistency is required at the cost of a larger binary. The presenter built a real app to test this, a system monitor showing real-time CPU and memory usage, written as a single TypeScript file. The build command is one line. The result is a single binary with no installer wizard, no node modules, no Chromium download. Two real problems surfaced. Reading CPU stats requires a system access permission that Deno demands be granted at build time, and Deno automatically hunts up the directory tree for a node modules folder and found a stray one in his home directory, causing a multi-minute stall. A single config line resolved it. The size numbers. The Deno system monitor binary came in at about 77 megabytes uncompressed, 21 megabytes with one compression flag. A better stack comparison built the same note-taking app in both Electron and Deno Desktop, Electron at 248 megabytes, Deno at 70. The entire gap is Chromium. Then the presenter deliberately deflates the size win. Better Stack also clocked startup time for both apps, and it was essentially a tie at around 370 milliseconds each. Deno Desktop's advantage is disk size and memory footprint, not raw launch speed. Beyond basics, Deno Desktop includes a system tray API, native notifications and dialogues, built-in auto-update that ships binary diff patches so users download kilobytes, not a full reinstall, and cross-compilation from a single machine to Mac, Windows, and Linux. The Windows and Linux installers are written in pure Rust, which is why they can be produced without platform-specific tooling. The section the presenter explicitly flagged as underreported is Electrobun, same core idea, but built on Bun rather than Deno. Electrobun went stable in February 2026, 4 months before Deno Desktop. Its numbers are sharper. The author reports a starter app around 14 megabytes and update patches measured in single kilobytes. The trade-offs. Electrobun is currently a one-person project and supports only Mac and Linux. Deno Desktop covers all 3 platforms, offers cross-compile, and has a funded company behind it. Experimental status caveat. Auto-detection covers 9 web frameworks, but single-file raw apps require manual entry point naming, and on Windows the app inherits WebView 2's quirks. Usable, but not a finished platform. Also from DIY Smart Code, a confident and opinionated breakdown of HTMX versus React. And to be clear, this isn't a balanced both have merits video. The presenter has a point of view, backs it with a real case study, and is also deliberate about telling HTMX fans where their tool falls apart. The hook was a visual demo. A button updating a number on screen, no page reload, no JavaScript the developer wrote. One HTML attribute. This is used to introduce the central claim. One real company used this approach to delete 67% of their React code. The core HTMX loop is summarized as request, response, swap. 4 key attributes. HXGET or HXPost defines where the request goes. HXTarget specifies which element changes. HXSwap defines how, replacing inner content, replacing the whole element, or appending. And HXTrigger defines when the request fires, which can be a click, keypress, form change, or even a repeating timer for real-time dashboard polling. The presenter's summary: any element, any event, any verb, any target. HTMX itself is approximately 16 kilobytes with 0 dependencies. React plus React DOM alone is roughly 45 kilobytes before the application does anything, and a real production SPA ships hundreds of kilobytes before rendering. The deeper idea is hypermedia. Rather than sending raw JSON, the server sends HTML with the next set of possible actions already baked in. The presenter argues this is what REST actually means as Roy Fielding originally defined it, and that the industry hijacked the word REST to describe JSON APIs. He also raises the concept of locality of behavior. With HTMX, you look at an HTML element and immediately see what it does. No tracing clicks through a dozen component files. The Context case study is the receipts promised in the title. Context rewrote their React application in HTMX. Documented results: 67% less code, JavaScript dependencies fell from 255 down to 9, build times dropped by nearly 90%. Supporting data: 48,000 GitHub stars, named #1 rising star in front-end, ranked as one of the most admired tools in major developer surveys. On where complexity goes: in React, state lives in 2 places simultaneously, on the server and in the browser, requiring a permanent API layer to keep them synchronized. HTMX keeps a single copy on the server and sends HTML directly. An entire category of synchronization bugs simply disappears. And because the server only needs to return HTML, any backend language works. The community calls this HOWL, hypermedia on whatever you'd like. For genuine client-side interactivity needs, dropdowns, toggles, animations, the recommended approach is pairing HTMX with Alpine, JS or Hyperscript, described as tools sprinkled in where needed. The presenter is deliberately hard on HTMX's limits. Wrong tool categories, spreadsheet-level applications like Google Sheets, real-time draggable maps, offline applications, anything with thousands of interdependent widgets reacting instantly. These are React's home turf, and it isn't close. He also acknowledges HTMX appears heavily in solo and side projects and far less in large enterprise frontends, for now. 3 common objections handled directly. Isn't this just Ajax and jQuery reinvented? Yes, kind of, but HTMX turned that old instinct into a clean declarative attribute system rather than hand-wired scripts. No JavaScript is a lie. Fair, the accurate claim is no JavaScript that you write. Every action is now a network request. Genuine trade-off: on slow connections, a snappy app can crawl. This is exactly why the partner libraries exist. HTMX4 is in beta, adding DOM morphing and streaming responses. The core pitch: the other 90% of the web is forms, dashboards, content, and CRUD, the boring stuff that's secretly most of everything. Now for some open-source drama. Brian Lunjuk covered a genuinely newsworthy story. A critical bug in the Rust-based clone of the GNU CP command, the standard Unix file copy utility, caused Ubuntu 26.1 build images to fail entirely. Not degrade, not produce warnings. Fail: Canonical temporarily reverted to the GNU original. Lunjuk had a calm but very clearly, "I told you so," energy throughout. He framed this not as a one-off, but as a structural, foreseeable problem rooted in 2 compounding issues. First, the edge case problem. The GNU Coreutils have been developed, tested, and refined over decades to handle a massive number of edge cases, different Unix lineages, platform variations, time zone handling, obscure behavioral quirks. He estimates thousands of such edge cases. The Rust clones simply have not had enough time to discover, document, and replicate all of that behavior. This alone, he argues, guarantees that when Ubuntu 26.1 ships, in October 2026, about 4 months out from the video, things will be broken. Second, the licensing problem, and this is the more structural issue. The GNU Coreutils are GPL licensed. The Rust clones are MIT licensed. Because of this license incompatibility, the developers working on the Rust clones are legally forbidden from ever looking at the GNU Coreutil source code. If even a single developer had reviewed the GPL source and then contributed to the MIT licensed Rust clone, the MIT license on the clone would be legally compromised. The practical consequence is devastating. Most of the edge case behavior in the GNU tools is documented only in the source code itself, not in external specifications or manuals. Because the Rust developers cannot look at that source, they cannot know what edge cases exist or how they are handled. Lunjuk's conclusion: it is not possible to produce a high-quality clone under these conditions, regardless of talent or money. He also surfaced the funding angle. Canonical has donated 40,000 British pounds per year to what he calls the Trifecta Computing Foundation. He expressed slight uncertainty on the exact name, specifically to replace GPL-licensed C and C++ code with Rust code that is predominantly MIT licensed. He suggested with some circumspection that a driving motivation for the entire Rust replacement effort is the desire to shed the GPL license, and that the MIT license is not incidental but may be one of the primary goals. He's careful to say the quality problem is not Rust's fault as a language. The same failure would occur if anyone tried to clone GPL software into a permissively licensed replacement written in any language, because the fundamental issue is the inability to reference the source being cloned. Canonical's vice president of engineering apparently declared that 100% of GNU Coreutils will be replaced with Rust MIT equivalents by Ubuntu 26.1 release. Lunjuk's recommendation is straightforward. Revert all the Rust replacements back to GNU Coreutils now and wait until the Rust versions are genuinely battle-tested. He says he predicted this pattern last year and was proven wildly more correct than expected. In the same Linux neighborhood, David Bombal put out a practical, step-by-step guide to dual booting Windows and Linux Mint on a modern laptop, with particular focus on modern obstacles that trip up first-time Linux installers, specifically BitLocker encryption and secure boot. Bombal's tone is patient instructor throughout. He opens by showing the end state already working. He reboots from Windows, Grub appears, Linux Mint loads, he shows LibreOffice running. Reboots again, selects Windows, Windows loads. That's what he's going to teach. The most important part of the video, which he emphasizes heavily, is what to do before touching any installation tool. Back up all data, resizing partitions can go wrong, and critically, disable BitLocker. He personally attempted the installation with BitLocker active and could not complete it. He walks through the Windows control panel path to turn it off. Before turning it off, he backs up the recovery key, and here's where he gets notably opinionated. He chose to save it to a removable USB drive rather than a Microsoft account, citing privacy concerns explicitly. He mentions that Microsoft has provided BitLocker recovery keys to law enforcement to decrypt users' computers, and recommends storing the key offline or printing it. He verifies BitLocker is off by checking disk management and confirming the lock icon is gone. On Secure Boot, the laptop has it enabled, but Linux Mint supports Secure Boot, so it doesn't need to be disabled for Mint. He cautions that other distributions might require disabling it. The toolchain: download Linux Mint from Linux Mint. Download Rufus Portable 64-bit from Rufus. Use a 16 to 32 GB USB drive minimum. He walks through the Rufus process, selecting the ISO, choosing ISO image mode rather than DD image mode, allowing Rufus to download Grub 2.12 because the image requires that version. He prefers to resize the Windows partition from within Windows Disk Management before running the Linux installer. He carved about 500 gigabytes from a 1.8 terabyte partition. To boot the USB without permanently changing BIOS settings, he uses Shift plus Restart, which takes Windows into the advanced boot menu. The live Linux Mint environment loads. He briefly shows LibreOffice and Firefox working to demonstrate internet connectivity via Wi-Fi. Then he reboots, confirms Grub shows both options, confirms both systems load correctly. He mentions he personally prefers Zorin OS for newcomers, but calls Linux Mint another excellent option, and notes the installation steps are very similar across distributions. Practical, no-drama walkthrough, exactly what a first-timer needs. Moving to a TED Talk with a really interesting argument, Tom Rizzuto made the case for physical media as a safeguard against censorship. Not from a nostalgia angle, but from a structural preservation one. His delivery was thoughtful, and he was deliberately careful to not sound like a pure anti-streaming crank, which actually made the argument more effective. He opened with the story of bone music, which was a practice from Soviet-era history, where young people bootlegged American jazz and rock and roll by cutting sound grooves into discarded X-ray plates, often preserving the original medical image on the record. The government had severely restricted access to American music, so citizens devised this underground method to hear, own, and share it. The records sounded poor, unsurprising given the medium, but they existed, and they were in people's hands. He immediately conceded that streaming's benefits are real. Previously hard-to-find music became instantly accessible to anyone with a phone, and he was self-aware about making a streaming media product, a TED Talk, to deliver this argument. He explicitly said he loves streaming and consumes it constantly. His central concern: a very small number of people now control enormous media conglomerates and have the unilateral power to remove content from streaming platforms instantly. He poses a series of pointed rhetorical questions about why they might do so: control, concealment, censorship, suppressing particular messages, and doesn't answer them definitively, but argues any of those motivations is plausible. Physical media, CDs, DVDs, cassettes, VHS tapes, keeps media in the hands of the public and makes it much harder to erase. The Soviet counterfactual he raises is striking. The American music those young people risked so much to share is credited, alongside other forces, with inspiring them to imagine societal change that contributed to the fall of the Berlin Wall. If all media had been streaming at that time, how easy would it have been for governments to simply cut off access? His second historical example is the film Nosferatu, which most people don't realize nearly ceased to exist. The film plagiarized Bram Stoker's Dracula without permission. The Stoker family sued and won, and as part of the court ruling, every copy of Nosferatu was ordered to be destroyed. The destruction order wasn't perfectly carried out. A few copies survived, and because of those surviving copies, the film exists today. His point is structural. Physical media, especially when mass-produced, is simply harder to fully destroy than digital content that can be switched off at the source. He closed by acknowledging he doesn't have a concrete solution, which landed as genuine intellectual humility rather than evasion. He floated two paths: a coordinated effort between media companies and creators, or an underground grassroots movement echoing bone music itself. His ask: treat physical media preservation as a genuine societal priority as the world moves further into the streaming era. Speaking of physical media preservation, Yang Ye put out a really useful corrective video about a viral PlayStation TOS story that's been spreading with important context missing. Here's the setup. PlayStation announced it will stop producing physical discs starting January 1, 2028, making everything released after that date digital only. The backlash was enormous. The announcement post garnered over 127.2 million views, and Yang Ye describes it as extremely ratioed, meaning the negative engagement far outweighed the likes. In the middle of that backlash, a specific clause in PlayStation's terms of service went viral and compounded the outrage. The clause states that if a user hasn't used their account for at least 36 months, PlayStation may close it. They'd contact the user via registered email, give them 6 months to log in or contact PlayStation to keep the account open. And if the account is then closed, the user permanently and irreversibly loses access to PlayStation online services and all digital products purchased through that account. Yang Ye's correction. The TOS page being circulated is specifically the UK and European version, identifiable by the PlayStation com/ngb URL. The American version at PlayStation com/NUS does not contain this clause. He demonstrates this live. The reason for the difference is GDPR, the General Data Protection Regulation, an EU law designed to prevent companies from retaining user data indefinitely. GDPR mandates deletion of all user data after a period of inactivity, and because user data is wiped, Sony has no way to link those users to prior purchases. Google and Microsoft have identical clauses in their European TOS, with even shorter inactivity periods than Sony's 3 years. This is not a Sony invention. The clause has been in place since GDPR took effect. The April 2026 update date on the page doesn't mean it was newly added. But here's his pivot, and it's a good one. The GDPR clause was written when physical media was still a viable alternative. If someone's digital library gets wiped, they could still have physical discs. With Sony eliminating physical media after January 2028, everything released after that date will be digital only, meaning this GDPR inactivity rule becomes a genuine existential threat to a user's entire library with no fallback option. He also notes that even imperfect physical media with DRM will have that DRM expire over decades, giving a much longer window. A digital-only library under this GDPR rule can be wiped in as little as 36 months of inactivity. So even the imperfect physical format offers substantially more durability. His critique of Sony isn't that they wrote this TOS clause. It's that their decision to eliminate physical discs is what makes the clause dangerous rather than merely inconvenient. He additionally criticizes Sony's broader motivations: cutting manufacturing and shipping costs without passing savings to consumers, eliminating the second-hand market where used physical games sell for $25 to $30 versus $70 new. He calls for support of the Stop Killing Games initiative as the legislative remedy. From digital ownership to labor disputes, the Electric Viking covered a dramatic story out of Germany. Mercedes-Benz demanding 90,000 workers absorb 260 extra unpaid hours per year, while simultaneously blaming absenteeism for Germany's industrial decline, even as the company's own profits collapse amid surging Chinese EV competition. The video opens with the German government's 34-measure economic reform package announced last Thursday by Chancellor Friedrich Merz. The most significant measure targets sick leave policy. Previously, German workers could take up to 3 sick days without a doctor's visit and obtain a full week-long sick note with a simple phone call. Both provisions are now eliminated. From day one of any illness, workers must have a medical certificate. The presenter says bluntly that people were exploiting this constantly, and he thinks requiring a doctor's note is reasonable, while inviting audience pushback. The numbers that frame the context: German workers average 15 sick days per year. British workers average 4.4, more than 3 times less. OECD data across 26 European countries ranks Germany 7th at an average of 3.6 weeks per employee per year. Then the Mercedes angle, which is the most striking part. Ola Källenius, the Mercedes-Benz CEO, was one of the loudest public voices demanding the government crack down on sick leave. He argued that Mercedes runs identical plants worldwide with the same health benefits and working conditions, yet Germany's sickness rate is more than twice as high as any other country, and called people taking unjustified sick leave not showing solidarity. The presenter adds a caveat that workers in developing countries might genuinely get sick more often, complicating that comparison. While Källenius was lecturing workers about attendance, Mercedes management simultaneously sent a letter to approximately 108,000 German employees describing conditions as dramatic. Contents: postponement of a contractual bonus worth 18.4% of 1 month's salary, originally due July 2026, pushed to 2027, affecting 90,000 workers. Management also pushed to shift the standard workweek from 35 hours to 40 hours with no wage adjustment. The presenter calculated that as 260 extra hours of unpaid work per year. An internal memo stated plainly, the cost per hour needs to drop. The response has been strikes at 7 German car plants, including Bremen and Berlin, organized by IG Metall. A large car convoy protest is planned for Stuttgart on July 9th, and the union is warning of a hot summer of production halts. 33,000 Mercedes employees are currently protesting. The financial backdrop explains everything. Full-year earnings fell from €10.4 billion to €5.3 billion. First-quarter profits fell a further 17%. Chinese sales dropped 27%. The share price has fallen 30% since January. And the cost to manufacture an EV in Germany is more than twice what it costs in China. The presenter's framing. Germany's industrial model was built entirely on combustion engines, and that model is breaking right now. Blaming workers for absenteeism does not fix a fundamental product problem. And speaking of EVs and Chinese competition, the Electric Viking also posted what was genuinely one of the more useful EV comparison videos you'll see, because it's from someone who actually owns 2 of the 3 cars. He's had the XPeng G6 for about a year and around 25,000 kilometers, the Zeekr 7X for about 9 months and 2,000 kilometers, and spent 2 weeks with a Subaru Trailseeker press loan, including dedicated off-road drive days. His son Kel, age 9, helps film and occasionally chimes in, which gives the whole thing a relaxed, family road trip feel. His surprise conclusion. The Subaru Trailseeker is the most enjoyable to drive overall, despite him owning the other 2. All 3 cars sit just under 4.8 meters long. Australian prices. XPeng G6 roughly 60,000 AUD, Zeekr 7X approximately 75,000, Subaru Trailseeker 70,000 for the premium with 20-inch wheels, or 63,000 for the non-premium with 18-inch wheels. He'd personally take the 63,000 version. The smaller wheels add 53 kilometers of range, 533 versus roughly 480. Battery and range. The old XPeng G6 with its 87 kWh NMC battery actually has the longest range of the 3 at 570 kilometers. The Zeekr has a 100 kWh NMC battery and 547 km range. The Subaru has the smallest battery at 75 kWh, a CATL NMC unit, and yet is the most efficient of the 3 at 533 km range on 18-inch wheels. Boot space. Subaru wins at 633 liters, significantly larger than the equivalent petrol Outback at 520 liters, made possible because the shorter EV front let engineers extend the boot. He demonstrates that a person can fully fit inside. XPeng is about 10% smaller at 570 liters. Zeekr is the smallest in practical terms despite being the largest car. Ground clearance and off-road. Subaru at 211mm with X mode in 4 settings, configurable hill descent speed control. Clear choice if any off-roading is needed. Zeekr has air suspension that raises or lowers but is road-focused, measured at approximately 165mm in its lowest setting, nearly 50mm less than the Subaru. XPeng is a road car only. Ride comfort and handling preference order stated explicitly. Subaru first, XPeng second, Zeekr third. The Zeekr's weight, 350 to 400 kilograms heavier than the other 2, is felt on bumps despite its adaptive suspension. The Subaru surprised him most, calling it sporty with a well-tuned suspension. Seats, Subaru best, ventilated, heated, comfortable even for sciatica sufferers. Zeekr close second but described as too flat for a performance car. XPeng clearly worst, he uses an aftermarket seat cushion. Interior quality though, Zeekr wins outright most premium materials, ambient lighting that syncs to music, large screen massage seats. His son Kel independently agrees. Software, XPeng has the best software by a clear margin, best app, best OTA updates. Zeekr's CarPlay fails to connect roughly 1 in 10 drives. Subaru has no app at all for the Australian market at time of testing. One genuinely annoying Subaru software issue. Region braking resets to the lowest setting every time the car is turned off. He says he almost rear-ended a car once misjudging braking distance. Charging, Zeekr at up to 450 kWh DC. XPeng faster than Subaru. Subaru the slowest of the three by a wide margin, though 22 kW AC on all three. Safety. The Subaru is the only car of the three that physically prevents the driver from driving into an obstacle. The Zeekr generates the most false positive collision warnings. Large red flashing alerts, he says, are genuinely stressful. The Zeekr-specific complaints are notable. Electric doors that are slow, glitchy, and sometimes fail to open when you're standing directly beside the car. He considers them potentially dangerous. Window switches reversed from expectations. And a magnet test revealed the Zeekr's body is almost entirely steel with almost no aluminum, contributing to its significant weight disadvantage. Performance: Zeekr 3.8 seconds to 100, 475 kilowatts. Subaru 4.5 seconds, 280 kilowatts, the fastest Subaru ever made, faster than any WRX SDI. XPeng 6 seconds, rear-wheel drive only, an AWD version is coming to Australia that will nearly match the Zeekr. In the final 2 weeks with all three cars present, the most driven was the Subaru Trailseeker. He says he never expected to enjoy a Subaru this much. That's everything from the last 25 hours. A genuinely packed day spanning AI strategy, agent infrastructure, developer tooling, Apple hardware leaks, open source governance, EV ownership, labor disputes, and consumer rights. Lots to think about, and the Nate Jones Imagination Framework and Raphael's post-launch monitoring architecture are probably the two worth revisiting if you have time to go deeper.